So welcome everyone. For this week, we will be learning something about the fundamental theorem of calculus. Fundamental theorem of calculus. From the word itself, this is a very important theorem in calculus simply because we will be applying and we will really see the application of calculus in life. Hindi lang siya puro solving. So meron siyang application. Okay? So before we dig into the details of doing this, just for you to see, we will be dealing with this formula. But of course, just like what was mentioned by your classmates a while ago, I shared this with you a while ago through an introductory video, and just as expected, your classmates didn't understand what was being presented. So better yet, let's discuss it now. Ready? So I just want you to be familiar with two terms in integral calculus. We have here, let me put the text. We have here the indefinite integral. That's the first one. And the other one is the definite integral. From the word itself, definite and indefinite. Would you like to give me an idea what comes to your mind when we say indefinite, and what comes to your mind when we say definite integral? By the way, if you will go back to our lesson for the past 4 weeks, 3 weeks, excluding your performance task, we kept on solving for the integral of the different derivatives, right? With the plus c at the end, if you can still remember. Which do you think, or to which do you think are those answers with the plus c at the end belong? Do they belong to the indefinite integral or to the definite integral? Kindly type your answer in the chat box. Where do you think do the answers in the different integrals that we just learned for the past 2 weeks belong? Indefinite integral or definite integral? One already answered. Okay, thank you. Thank you. Now let's keep the answers coming. I also challenge all the rest to please try to think about this. Where do those integrals belong? Indefinite or definite? Okay, the ones with plus C. Okay, thank you. So your classmates, many of your classmates, majority have shared or have mentioned indefinite integral. Well, that's actually correct. So let's say, for example, we have this given. So we have the integral of 4x dx. Okay, let's find the integral of 4x dx. So this will be equal to 4, the integral of x dx. I hope you can still remember the process. This is the constant multiple rule. And after that, let's now get the integral of this. This will become 4 times, what will we do with this? Add 1 here. So x raised to 1 plus 1. And then whatever your exponent, copy it in the denominator. I hope you can still remember the process. Then plus c. So we will end up with 4 and 2. So we will have here 2x squared, right? Plus c. Okay. So this is actually an example of indefinite integral. From the word itself, indefinite. Any value can be substituted here. And from the video that I presented a while ago to you, it says there, no boundary. So therefore, the value of x is still unknown. And that's what makes it indefinite integral. We are not yet sure of its value. Can you follow? Show me a reaction if that is clear to you. Okay, see, it's now clearer. This is what the video a while ago presented to you. Okay, now let's move on with the definite integral. And this will be our topic for this week. So from the indefinite integral, we will be moving on to the definite integral. Meaning, in here, there will be a boundary. And that is this. Those are the symbols, the A to B. From A to B, that will be the boundary of our definite integral. If we will look at this in graph, okay, let's have this as an example. For the indefinite integral, yan, and then the definite integral, okay. So for example, this is our Cartesian plane and we have a curve. Remember, in the calculus, that's always the curve. So for example, this is the curve. Yan. There's a curve. Okay. And so, and then there is this x-axis. Ayan. So, in here, talking about the indefinite integral, actually, when we solve for this, we are solving for the area. So we are dealing with this, but not this. Take note of this. This is not included. This is not included. Because, take note of this, the definite integral does not necessarily denote the area under a curve. It only does when the curve is above the x-axis on the closed interval a, b. So therefore, hindi natin ito kakailanganin kasi for the indefinite integral, it has no boundary. But for the definite integral, it will show us or we will be dealing with boundaries. For example, this is our Cartesian plane. Yan. And assuming that this is our curve, okay, it's a parabola. Okay. And then we have our A and B. For example, this is 1, 2, 3, 4, 5. There. So we have 1, 2, 3, 4, 5. If we will look at this, the whole area bounded by the x-axis and the curve is actually this, all of this. This is actually the area bounded by the curve and the x-axis. So for the definite integral, we will be dealing with the area covered or bounded by the curve and the x-axis. However, we have our A and B boundaries. May boundaries tayo. So if the boundary is about from -2 to 5, well, that's okay. Dito papasok yon. The integral of -2 to 5. Can you follow? So therefore, from here, from this point up to this point, yan, the area enclosed by the x-axis and the curve will be the value for your definite integral. Can you follow? Now, it's also possible that not all the area or not all the part of the curve or not all the area bounded by the x-axis and the curve is the one that we are solving for the definite integral because it's possible na meron ding boundary. Meron ding boundary at putulin natin yung boundary na yon. How is that? For example, the definite integral tells you to get the area of the area bounded by the curve and the x-axis from 1 to 4, then we will have a different coverage for this. So from 1 in the x-axis up to 4, There you go. Then, with this kind, this is the only area that we will be solving on for this given. Oops. This will only be the area that we will be solving because our definite integral tells us the boundary, which is from 1 to 4. Can you follow? So therefore, this is the area that we will be solving on for the definite integral. Show me a reaction if that concept about definite integral is clear to you. Okay, let me see. Okay, very good. That's it. Oh, that's the explanation given to you by the introductory video a while ago. Oh, whom do you want to explain? The introductory video a while ago or yours truly? Yung walang halong pambobola. Okay. Thank you so much. Okay, so let's now move on. Now, definite and indefinite integral are now clear to you. Again, for the indefinite integral, it doesn't have boundary. But for the definite integral, it has boundary. Okay? Now, let's continue with this. What if our given tells us like this? Game. If, for example, we are asked to find the integral, or we are asked to find the definite integral of, let's just use this process, 4x dx bounded from 1 to 3, for example. So this one now, we will be using this formula to solve for this. So, of course, the first step is to get its integral. Can you follow? The first step is to solve for the integral. And we just solve the integral of this. The integral of this is, we have here this will be equal to, let's enclose this in a bracket, 2x squared plus c. Okay? Can you follow? But this time, since the c is really unknown, it's not anymore necessary for us to write c in here. Okay, please take note of that. Though in our process, we will be getting the c. After getting the integral, when we apply the definite integral, we will already remove the c. Please take note of that. Okay, so enclose it in a bracket, and then we will put the boundary. So the boundary is from A to B. That's from 1 to 3. Can you follow? And so we will now be applying this formula. The function, substitute the value of x, which is b, and then subtract it to the function, substitute the value of x, which is a. Okay, which is, in this case, this is our b. This is our a, and this is our b. Okay, so let's now do this. This will become, are you ready? So we have here f of 3 minus f of 1. Okay, and so let's just substitute the value of x, which is 3, and then the value of x, which is 1, with our given function. So let's do this. We will have 2 times the value of x is 3 squared minus, in here, for the f of 1, we will have 2 times the value of x, which is 1 squared. We just substitute. And then after that, we will have here 2 times 3 squared is 9 minus 2 times 1 squared is 1. Then simplify this further.